4,600,000,000 years ago, our sun ignited an inferno that makes every modern solar storm look like a struck match. A cosmic flamethrower. In its youth, during the first 100 million years of its life, it hurled plasma bombs into space that were 1,000 times stronger than anything we measure today. Magnetic eruptions so violent they could have blown away entire planetary atmospheres, radiation that could have shattered DNA itself. And yet, we are here. Earth survived. Life emerged, against all odds. But the question that has tormented astrophysicists for decades is not how we survived. The question is, why did we overlook the evidence for 4 billion years that we should not have been able to survive at all? Welcome to a story about the most dangerous phase of our sun and the disturbing realization that we have completely misunderstood it. Let us remember the 1st of September, 1859. Richard Carrington, a British amateur astronomer, was observing the sun through his telescope in Redhill, Surrey. What he saw had never been documented by any human before. Two brilliantly bright spots of light on the solar surface. They appeared suddenly, intensified within minutes, and disappeared after 5 minutes. 18 hours later, all hell broke loose on Earth. Telegraph lines exploded. Sparks flew from equipment. Telegraph operators received electric shocks. In some offices, papers caught fire, and over the entire planet, from tropical Cuba to northern Australia, the sky glowed in red and green, auroras visible at the equator. The Carrington event, the strongest geomagnetic storm in recorded human history. But here is what's disturbing. By modern measurements, the Carrington event was an X-45 flare. Enormous, yes, but compared to what the young sun produced, it was a whisper compared to a scream. Let us jump to the year 1982. A team of astrophysicists led by Jeffrey Linsky analyzed spectral data from young sun-like stars, stars that had just started their fusion. T-Tauri stars, as we call them. Stars aged between 1 and 10 million years. What they discovered fit no model. These young stars produced X-ray radiation 10 to 10,000 times stronger than our current sun. Their chromospheres, the layer above the photosphere, were 100 times hotter, and their coronal mass ejections, the data were so extreme that many scientists initially dismissed them as measurement errors. But the measurements repeated, with every telescope, with every young star we observed. The reality was inescapable. Young stars are monsters, and our sun was once one of these monsters. Linsky published his findings. The paper was cited, discussed, then forgotten, not intentionally, but because the implications were too uncomfortable. Because if our sun was so active in its youth, then early Earth should have been a radioactive hell. Its magnetic field, weaker then than today, would have offered barely any protection. The atmosphere would have been blown away. Water would have been dissociated. Hydrogen escaped into space. Earth should have become what Mars became, a dead, dry desert. But then, in the 1990s, geologists found something peculiar. Zircons. Tiny crystals older than 4 billion years found in Western Australia, the oldest known minerals on Earth. And in these zircons were inclusions, traces of oxygen isotopes that can only form in the presence of liquid water. Liquid water. On an Earth that was 400 million years old, at a time when the sun was a flamethrower. That made no sense. If the young sun was as active as Linsky's data suggested, then there should have been no liquid water on early Earth. The radiation alone would have boiled every ocean and blown it into space. But the zircons did not lie. Geological records never lie. So something else must have happened. Something we did not understand. The answer came from an unexpected direction. 2018, the Parker Solar Probe was launched. A mission designed to fly closer to the sun than any probe before. Its goal, to study the corona, the sun's outer atmosphere, where temperatures rise to millions of degrees even though the surface is only 6,000 degrees hot. One of the greatest unsolved mysteries of solar physics. But Parker discovered something else, something no one had expected. Magnetic filaments. Thin, dense structures in the solar wind, remnants of massive magnetic arcs that had detached from the solar surface, and these filaments interacted with planetary magnetic fields in unexpected ways. They amplified them. Do you understand what this means? If the young sun produced more massive magnetic eruptions, and we know it did, then it also sent more densely packed magnetic structures into space. And if these structures struck Earth's young magnetic field, they could have temporarily strengthened it, just enough to deflect the worst effects of the superstorms. It is as if the sun beats its own children, while simultaneously giving them a shield to defend themselves with. A paradoxical system, violent and protective at once. But here, the story becomes dark, because not all planets were lucky. Mars, similar in size to Earth, in the habitable zone at least partially, with a dense atmosphere as we now know, liquid water on its surface, perhaps even life. And then, nothing more. About 3,800,000,000 years ago, Mars lost its global magnetic field. The reason remains unclear to this day. Perhaps its core solidified too early. Perhaps a massive impact struck the planet and disrupted its dynamo. Whatever happened, without a magnetic field, Mars was defenseless. The young sun, still active though no longer as extreme as in its first 100 million years, bombarded Mars with solar storms. Without a magnetic field, the charged particles penetrated directly into the atmosphere. They tore atoms from their bonds. Molecule by molecule, the atmosphere was blown into space. Within 100 million years, Mars was dead. And here's the disturbing truth. It could have happened to us too. Had Earth's magnetic field been even 10% weaker, we might not have had enough protection. Had the sun been even 20% more active in its youth, even our magnetic field would not have been sufficient. We exist in an incredibly narrow window of possibility. But there is a second puzzle, one that has plagued science since the 1970s, the faint young sun paradox. According to stellar evolution models, the sun was about 30% less luminous 4 billion years ago. With less luminosity, less heat reached Earth. By all calculations, Earth should have been completely frozen, a snowball planet. Yet we know there was liquid water. The zircons prove it. Geological records show sedimentary rock that can only form in liquid water. How can both be true? A faint, cool sun and a warm, water-rich Earth? The answer being discussed today is as elegant as it is disturbing. Greenhouse gases. Enormous amounts of carbon dioxide and methane in the early atmosphere that trapped enough heat to keep the oceans liquid. But where did these gases come from? Volcanism, most models say. The young Earth was geologically hyperactive. Continents formed and collided. Volcanoes spewed gas into the atmosphere continuously. But new research from 2024, based on isotope analyses, shows something surprising. Part of the carbon dioxide may have come from outside, from comets and asteroids that bombarded Earth. These impacts, which we consider destructive, may have actually kept Earth warm, long enough for life to develop. The universe, it seems, has ways of turning catastrophes into blessings. But let us not forget, the sun is no longer young. It is now 4.5 billion years old, stable, predictable. Its eruptions are gentle compared to its youth. Or are they? 2012. A coronal mass ejection stronger than the Carrington event missed Earth by 9 days. Had it hit us, we would have experienced a global power outage, satellites would have failed, GPS collapsed, transformers melted, damage in the trillions, months perhaps years to recover. And that was from the old stable sun. Imagine what the young sun would have done. The research published today, the studies about the young sun as a flamethrower, they remind us that our existence is not self-evident, that we live in an extraordinarily favorable moment of cosmic history, and that when we search for life on other planets, we should not only look for water and atmospheres, we should look for magnetic fields, for planets strong enough to withstand the fury of their young stars. Tonight, when you go outside and the sun has set, remember this. That calm yellow star that rises over us every day was once a monster. It burned, it hurled, it could have killed us, but it did not. Perhaps through luck, perhaps through a precise tuning of physical laws we do not yet fully understand, perhaps through a magnetic shield that formed at exactly the right time, or perhaps, and this is the most disturbing possibility, perhaps the universe is full of dead worlds that did not survive their young stars, and we are a rare, precious exception, an anomaly in the cosmic data set, a miracle we should never take for granted. The story of the young sun teaches us humility. It reminds us that life is fragile, and that we have been extraordinarily lucky. If you enjoyed this video, leave a like and subscribe to the channel. Science evolves every day, and I'll keep you updated on the stories that truly matter. Until next time, stay curious and stay grateful.